Hello everyone, and welcome to another GIS lecture video. And in this lecture video, I want to wrap up our discussion on rasters by talking about this idea of attributes in rasters. So if we remember back to vector data, right, we had this idea of an attribute table that contained many different attributes about a given geometry. Now with rasters, right, this works a little bit differently. So if we go give ourselves some space here and we go back to this concept of rasters, right, if you remember, I talked about this value when we talked about the raster data structure. And I said that this value was where the attribute goes. So I want to go down for a second, and I want to basically, this is going to be a shorter video where I really just want to make one point abundantly clear, right? Right, for attributes in raster data. Right, so basically what will happen is each attribute requires its own raster. So put another way, right, a raster can only hold one attribute, right? A pixel can only hold one value. Okay? Let that sink in for a second. A raster can only hold one attribute. A pixel can only hold one value. Okay? I think to make this point the most clear that I can, I want to compare and contrast the vector data with the raster data model. Okay? And so what we're going to do is I want to imagine that we're doing rainfall. Rainfall over time. Right? And so what we're going to do for the vector data side, right, is we're going to have three weather stations, right? 1, 2, 3. So these are all weather stations. Right? Okay. So vector data, as we've mentioned before, has an attribute table. So we have 1, 2, 3. And we'll say we're going to leave some space here, right? So for raster data, right, let's say that we have, I'm not going to bother specifying a spatial resolution in this case, but we have something that looks like that for raster data, right? These would normally be evenly spaced grid cells, but I suck at drawing. So let's say we are starting this back in 1990, right? And we measure some rainfall. Weather station 1 measures 12 inches. Weather station 2 measures, say, 7 inches. And weather station 3 got a deluge and it measures 36 inches, which is 3 feet of rain, which is absolutely insane. Okay? So these values go into this attribute table in the first column, right? So this is the rainfall at weather station 1 in 1990. Okay? So let's say we do the same thing with raster data, with raster data, right, this grid cell maybe had 5 inches of rain. This grid cell maybe had 6, 8, right? Approximately the same locations. This would have maybe say 20, 35, 30, right? This maybe have 7, 4, right? I'm making up numbers at this point, but you get the idea, right? That for the raster data, right, each grid cell has a value that represents the rain in that area for 1990. Okay. So let's say we jump forward 10 years and we're at 2000, the year 2000, and we want to measure rain again. Well, what happens to the vector data? All we have to do for the vector data is add a new column into the attribute table and say maybe it was a dry year. So 3, 2, 5, right? What about vector data? Well, we can't overwrite these, right? We can't just add another value. What we have to do is we have to duplicate this entire structure. Right, so we now have a 2000 raster with values in it. So since it was a drier year, we'll keep the values kind of low. Maybe this area had a little bit more rainfall, right? So now we're at 2010. Right, again, if we want to use vector data, all we have to do is add another column to the attribute table, right? We haven't changed the geometry. We haven't done anything other than add one column to the attribute table. Let's say this was a particularly heavy rainfall year. So we'll say 24, we'll say 14, and we'll say 32, right? If we want raster data, right, we can't just add numbers to the existing pixels. We have to duplicate the entire raster data structure again. Right, and then put some numbers in here. Oh, I just realized this was originally a 3x4 and these are 3x3s. These would all be the same size. But again, right, the idea is that we would have the key point that I want you to take away from this is that when we had vector data, if we wanted more attributes, all we had to do was add a column to the attribute table. We didn't change the underlying geometry necessarily if we didn't want to. All we had to do was add another column, and everything for weather station 1 is associated with this row in the attribute table. When it came to vector data, we had to duplicate the entire data structure 3 different times. So we ended up with 3 rasters, 1 for each year. Okay? Hopefully this illustrates the point that I'm trying to make. That with vector data, it's easy to have multiple attributes for a given location. With raster data, you end up having to duplicate the entire data structure every time you want to add an additional attribute for a location. Right? This area right here, right? If we want to know the rainfall in this area right here for 3 time periods, we have to have an entire raster for 1990, an entire raster for 2000, and an entire raster for 2010, right? As opposed to here, right, adding another year is just adding another column onto an attribute table, which is much less resource intensive. So hopefully this makes sense. And as always, if you have any questions, please reach out. Thank you.